Welcome back to another exciting day of Leetcode. Today we're doing a 33 search in a rotated sorted array. So there's an array sorted in ascending order with distinct values. That's going to probably be important later because they bolded it. Prior to being passed to the function, the array is possibly rotated at an unknown pivot k such that, whoa, that's confusing. Okay. Oh, rotated from 1 to the length, but not 0, so we can't start at 0. Interesting. Okay, so 0, 1, 2, 3. So this part goes on to the front, and then the rest goes on the back. Okay, so from k till the end of the array, you stick it on the front, and from the beginning of the array, the old beginning of the array, up to k, you stick it on the back after that stuff. So yeah, it's I get it. It's rotation-like, sure. Okay, given nums after the possible rotation. Interesting. So it's not for sure rotated, but it's possibly rotated. And an integer target, return the index of target if it's in nums, or -1 if it's not in nums. Write an algorithm with O of n runtime, log n runtime complexity. Interesting. Interesting. Okay, so the main challenge here is obviously the log n complexity. The search itself is super straightforward. I mean, you could just loop through the array and return the index of the target and you're good to go. So, I mean, like the most agnostic solution is like in location equals -1 and int I equals 0, I is less than there's that length I plus plus. Whoops, it's called nums, search is the name of the function. So if, when you're in an interview situation, writing up the easy solution like this isn't a bad idea because, you get it out of the way, right? And you have something that works. Whereas if you try to show off and just go straight to what's probably going to be like a binary search would be the correct answer, it's that kind of showboating. You might not end up with a working example. Whereas I wager this is probably going to get 90% of the way there. Of course, it's not going to be good. I mean, that's, simple linear search right there. Yeah, I mean, this is complicated because there's like, in a binary search, your ability to split it in half or leap ahead and stuff is conditioned on the fact that it's in order. So if it's not in order, I'm just going to submit this and see how it does performance. So it'd be funny if this didn't pass certain test cases. Runtime beats 100%. That doesn't seem accurate. It looks like this one's bugged on Leetcode because that's like all of them. And then the fastest finish yet, by the way, and beats 50% on memory. Wow, okay. But it's not O of log n, as the interviewer would say. And therefore, you are not entitled to work here at the Google. Get the fuck out. Okay. I would argue that while it is O of n, no, I have no argument, actually. I can make it a little bit better, but I don't think it'll be log n. It'll depend on some math, but alright. Yeah, you don't know the pivot, and to find the pivot would cost you a considerable amount of time, of processing time. The minimum amount of time that it would require you to find the pivot is a binary search, I think. Best case. You're looking at, is the stuff to the left bigger than the stuff to the right? You've got to find that point. You've got to find that break right like there where the pivot occurs. And so the minimum amount of time to find that, I think, would blow through your row of login budget already. So I think you have to complete this problem without being able to find the pivot. So you just have to deal with it. Yeah, it's an unknown pivot. Okay. All right. So one simple thing you can do is track the break boolean after pivot equals false. I wonder if this will reduce my... I can't really improve my memory performance, actually. I don't know how people did better on memory complexity than this. It's like I barely have any variables. Come to think of it, that's pretty bizarre. Hmm. I don't know. Maybe stream operators reduce the memory overhead? I mean, I'll do one of these with stream operators one day. I gotta research the syntax a bit before I jump into that, though. All that map and filter and reduce stuff is too much. Oh man, you know what? Map and filter and reduce could probably crush this. Filter could probably crush this because filter is mad performant. Yeah. All right. Maybe that's how you do it. But anyway, dumb solutions. So you want to search until you found the pivots. You know you've found the pivots when the value that you're at is bigger than the next one. So if nums of I, well, if I is less than nums.length minus 1, don't want to mess that up. If I plus 1 is less than nums.length. I like that phrasing the best. Okay, if nums of I is bigger than nums of I plus 1. This is also a weird question because all of this stuff that I do adds like compares to it. And so even though it makes the big O complexity improve potentially, the addition of those extra comparison stuff raises the value of that factor of k, and so it's probably still going to end up being less performant than the dumb solution. So like really I don't think you can do better than I started with by much. Unless you have some kind of fancy trick that I'm not aware of, which is probably the case. Alright. So then you've detected that we are now after the pivot. Here we can do an early abort. So if nums of I plus 1, if nums of I, everything to the right of this point is going to be smaller than the first thing in your array, right? So everything beyond that point is smaller. So if the target is bigger than the first thing in your array, then you can early abort here. You're done. Right? So this is early abort if you reached the pivot point and your target is larger. Wait. Larger. Oh, there's actually two cases. So either your target is... Well, no, it's not going to give you like a negative value target, is it? No, I don't think it'd be a problem. If you reach the pivot and your target is larger. Yeah, because everything to the right of the pivot is going to be smaller than the first value. They were in ascending order. Up. Okay. I doubt it's much of an improvement. Sure. This tiny improvement gives a wrong answer. That's funny. Yeah. So if target is greater than, so the target's 5 here. It reads 3. It reads 5. Oh, I just did these out of order. Oops. Well, that's entirely my bad. Yeah, obviously, if you find the number, you've got to gotta terminate. Yeah, stupid. I'll add that to my test cases, though. I'm not really using much today, since this one is so obnoxiously simple. How is this a medium? This is like at best an easy. I mean, I guess it's that O of log n portion of it, but whatever. Be 80%, 100% runtime. Come on. How much better than that? Okay, so with the early abort, you are. I mean, it depends on how the target's chosen, and it depends on how the pivot is chosen, right? Because if the pivot's chosen at random, let's kind of draw this out. Okay, let's say we have an array. Here's an array of stuff. If the pivot's chosen at random, then on average, it's going to split it in half. Okay, and this half moves in front, and the other half moves in back. So this is, small half, big half. I like how I copied it when they're just the same stars. Okay, so in that case, if the target is bigger than this guy, which is the smallest number in this, but is also the largest number in this, it would go on the end here. Oh, that's the clever part. There you go. So if the target is bigger than the first number in the array, you start scanning this way. And if the target is smaller, then you start scanning that way. There you go. See, that's simple. All right, let's write it out. All right. All right. So if nums of 0 is bigger than the target. No, let's do the simpler one first. Let's see. The target must be in the big part, the left part. Okay. Then we do this until we've reached the pivot. If the target is, well, I shouldn't say must be. I'll just say, yeah. Man, it's kind of wordy, but okay. Else the target must be in the small part, in the right part, or it doesn't exist. So here I want to, and I can actually skip ahead to 1 there, which is lovely, because I've already checked. Well, then I'd have to check if it's equal and whatever. I don't want to do that. Yeah, sure, I'll do that. Why not? If nums of 0 the array is at least one long, right? Yeah, so this won't trigger an edge case. Early return for target equals first item. I mean, this is rare, but sure. Okay, so if the target is in the small part, the right part, then I want to start from the rear. Just rewrite this for loop accordingly. So we are going to start from nums.length -1. Yeah, I mean, no, because you don't know where the pivot, you don't know where this break occurs. So you can only start here, knowing that you can either go that way, forward to go through the large bit, or you can go through the small bit until you find that bit. So it is actually a question about finding the pivot when it came down to it. This is a clever one. I like this one, but I still think that this is basically an easy in terms of difficulty, just because there are so many trivial solutions that are almost as performant. But maybe if you're an interviewer and you're like, you have to get this answer exactly, then it's a medium, because I think this is the ideal solution. Okay, early abort if you reach the pivot point and your target is larger than everything. Smaller than. So it would be smaller than everything that was right of the pivot. I should call this in the left bit. Everything in the left part. I'll even leave this in my comment. Given, we'll call this the big part. You could tell I love comments, right? Pivot. The small part. Okay. Yep. That suffices, I think, to explain it. Okay, so we're going backwards. I minus 1. Return if we find the target. So if I minus 1 is greater than or equal to 0, and okay, so when do I know I've reached it? So this will be the smallest, and then the guy at -1 will be larger, right? So the guy at nums of I -1, I could flip the sign instead, but I think I like this better. You reach the pivot point, and your target is smaller, everything left bar. Okay. Yeah. If target, I actually don't even need that statement, because I'm already going to roll in the right direction regardless. Yeah, I'm always going to roll in the right direction. So I don't need that anymore, because I already checked it over there. Nice. Wow, this is beautiful. It's flavorful. It's beneficial. Okay. I guess I'll include my comment. Why not? Make it nice and long. Wow, look at all that. Probably a typo in there somewhere. Yeah, alright. Oh, I -0. I see it. If I -0 is greater than 0. Sure, let's try it out. Let's see how much better and or worse it is. It's equally 100%, but now it beats 90%. Well, this one was piss easy. Just goes to show you that whether or not you get a job at the Googs is completely luck of the draw, because this was rated the same as the one that I did 2 times ago, number 31, which took me like an hour and a half. So the moral of the story is just interview repeatedly until you get one like this. And then don't give up. All right. Thanks for tuning in to this short one. See you next time.